Yes, welcome once again to DC Economics. So this is Econometrics. So we're going to talk about the accurate and reliable estimator. So we begin by understanding what is an estimator. An estimator, this is a statistical or a function of the data used to estimate a known parameter in a statistical model. It is essentially a method or a rule for calculating an estimate based on observed data. So sometimes people define an estimate as a rule of calculating an estimate of a given quantity based on observed data. So that this rule quantify of interest and is related or distinguished in one way or another. So as actually the estimator behaves for any given sample, the estimate of beta estimated will be probably not equal to the true value of the beta. So difference between the B estimated and the beta not that is not estimated is what is known as estimation error. So the estimate will be different for different samples as well. This is also another behavior of an estimator. So we may ask ourselves that how do we define an accurate and reliable estimator? Remember, to define an accurate and reliable estimator, we need to consider the two issues. First of all, in order we can determine the accurate and reliable estimator, we need to consider the mean and variance of the sample distribution of the estimator. So we actually use mean to define accuracy, and we use variance or the standard donations or the standard deviations to define the reliability. So for an estimator to be accurate and reliable, the mean and variance must have the specific properties. So we define accurate and reliable estimator by considering the mean and variance. So what we need to understand about for an estimator to be accurate and reliable, the mean and variance must have a specific properties. And the first property is is what is known as the small sample properties. The first properties is the small sample property. So as I told you earlier, the estimate of B estimated is a random variable because its value is uncertain from sample to sample. Uncertainty actually is measured by the amount of error in an estimate of mean or average value of the population. And the uncertainty, this refers to the epidemic situations involving imperfect or unknown informations. So for an estimator to be accurate and reliable, the mean and variance must be taken into consideration, as I told you earlier. So the mean and variance must have specific properties, and one among the properties is the small sample properties. The small sample properties. So the small sample properties of an estimator are the properties that the mean and variance of the sample distribution of an estimator must have any finite sample size. So for an estimator to be accurate and reliable, the small sample properties of an estimator are the property that the mean and variance of the sample distributions of an estimator must have any finite sample size. Remember now, these two small sample properties we are talking about includes the unbiasedness, that is the accuracy, together with efficiency. That covers the efficiency means the reliability, but also unbiased means accuracy. But also we have inaccuracy, that is known as biasness. So these three properties actual are unbiasedness, that is accuracy, and second efficiency, that is reliability, cover the three sample properties of and what is known as small sample properties of an estimator. So for an estimator to be accurate and reliable, it must have the two small sample properties, that is unbiasedness, that's accuracy, efficiency, that is reliability, but also inaccuracy, that is biasness. So under what is known as unbiasedness, that is accuracy, An estimator is unbiased if the mean of the sample distribution is equal to the value of the population parameter being estimated. So the mean of the sample distribution is equal to the true value of the population parameter being estimated. So that is given by expectation of B estimated, that is the mean simply, that is equal to the expectation of the mean simply, that is B estimated, which is equal to beta naught, that represent the population parameters. So it's given by expectation of B estimated, which is equal to beta naught, or expectation of X, that is equal to beta. Second is bias. Bias is also known as inaccurate estimator. So this simple property is that an estimator is biased or inaccurate if the mean of the sample distribution does not equal to the true value of the population parameter. So an estimator is inaccurate if the mean of the sample distribution does not equal to the true value of the parameter. So an estimator is biased upward downward if the mean is above or below the true value of the parameter, that is given by expectation of beta naught, which is greater than beta, and the expectations that is given as beta estimated, which is less than beta, as you can observe. But also let's talk about the efficiency, that is reliability. Another small sample properties include the efficiency or the reliability. Under what is known as the efficiency, that an estimator is most reliable if it is efficient. So an estimator is efficient if it has a minimum variance in the class of unbiased estimators. So if there are two unbiased estimators, that is given by if there are two unbiased estimator of beta 1s denoted by beta 1 estimated, and we have also the beta 2 estimated, then the beta 1 estimated is the efficient estimator if the variance of beta estimated is less than the variance of beta 2 estimated. So this is given by taking the variance that of beta estimated less than the variance of beta 2 estimated, or sometimes we call the variance of beta 1 estimated less than the variance of beta 2 estimated. So for an estimator to be accurate and reliable, as we observe, we need to consider the mean and variance. So after talking the small simple properties, we can observe an example. We have y, which is equal to beta naught plus beta 1 estimated, x1 plus beta 2 times x2. Then y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, as you can observe. So those actually, the model shows out on how beta 1 are less than on the given variance. Another property is the small simply random error. This is another key concept under accurate and reliable estimator. So under sample error is a random estimation error that occurs from sample to sample because different samples have different subset of units from the population. So this is a result of chance. So an efficient estimator are the smallest sample error of an unbiased estimator. So an efficient estimator is the one that has the smallest sample error, as what is known as the smallest sample error of an unbiased estimator. Another key properties under reliable, accurate and reliable estimator, let's talk about the standard error of an estimator and precisions. The standard error of estimator and precisions is that an efficient estimator are the smallest standard error of an unbiased estimator, and therefore now the smallest average estimator errors occurs. So an efficient estimator has the smallest standard error of an unbiased estimator, and therefore the smallest average estimator's errors occur. Therefore now an efficient estimator will be the most precise estimator. So that is how we can actually capture the concept about an accurate and reliable estimator. So we have talked about the small sample properties, the sample random error and the standard error of an estimator precisions. So that's marked the end. Welcome to this economics. Bye bye. This is Econometrics. Don't forget to watch on other videos. I wish you a nice moment.